In the previous video, we learned what a graph is. We gained insight into both the mathematician's view and the computer scientist's view. Now, we want to look at the big picture of graph analytics. Why are we doing what we are doing? And why do I need a graph representation and graph analytics? Let's start with a graph network which you may already be familiar with, Facebook. Here is my Facebook page. Let's look at it and consider some of the elements it contains. There is a primary user, and that's me. They're my friends. And typically there are some posts, some of which may have media in them, such as video. What else does it have? Well, let's consider what's inside a post. The post contains text. It has tags. I tag some people. Some people comment on my post. If somebody is commenting, then that means there must be a commenter who is also a user in the Facebook. Other people like my post, or they like a comment, and they also respond to some of the comments. Many posts have locations associated with them as well. When we consider all of these together, do you see the graph? Well, if not, we'll show you. Here we see very much the same types of information, but now they're in a graph. First, notice me on the far left. If you look carefully at this graph, you'll also notice there are relations labeled friend of and created post and parts of the post and everything that you saw before that are now organized in terms of objects and relationships between objects. The objects here are the post, comments on the post, replies to the comments, and so forth. And the relationships also include tagged in or refers to. So this is sort of the big picture, right? Next, we will look at 4 specific use cases in 4 different disciplines. The first one will be on social media. The second one will be on biology, where we'll look at genes and diseases. The third one will be human information network, which means personal information. And the fourth one will be on smart cities. Let's go through these examples one by one.